Hello class, Tarmo here. This is week 10 and today's tutorial is going to be all about 3D visualization using GIS data and extrusion. I'm going to have a few examples to show you. I'm going to start off with my first example coming to us from Manhattan, New York City in the United States, and we're going to be looking at building heights and the extrusion of buildings to produce 3D virtual reality settings from our GIS data. So the first thing that I'm going to point out is that this example I'm going to do using QGIS. I currently have QGIS installed and open. It's currently completely blank. And before we begin, I'm going to make sure that we have two very important plugins installed that are going to allow us to do the kinds of things that we want to do today. So if we go to the top bar here and we click on plugins and then go to the manage and install plugins option. It will, if you click on the installed part, it'll tell you what's on your computer. You can see whether or not it's already installed or not. If it is and it's checked off, you're good to go. If it's not, you can simply search for the plugin here and then choose to install that plugin if it's not on your computer already. The two that we want to ensure that we have on our systems for today are this one here, QGIS2 THREEJS. It's a JavaScript plugin that's going to allow us to do some pretty interesting three-dimensional work with our QGIS data. And the second one is the one directly below it here, Quick Map Services. This is a way by which we can very quickly add a backdrop or a background geographic data set for context. So if they're not installed, search for them here and then click on the install plugin. The button will show up somewhere down at the bottom of the menu and let it do its thing. It's going to add some buttons onto your toolbar, and when you're all said and done, they'll have little check marks beside them and they should show up under the installed tab. I'll give you a second to check. Okay, so I've already got them installed, so I'm simply going to close this. And what I'm going to do is show you a website. I'll provide you the link much larger in the post-processing stage. You should see it on the screen shortly. But it takes you to the metadata from the City of New York. So City of New York metadata, we have building footprint data. So we can see what it looks like. We've got a backdrop here of some imagery, very high spatial resolution, good detail imagery. And in yellow, we have the building footprints, or the outlines or the boundaries of the buildings as polygons recorded into a GIS data layer. So if we want to know more about this, we can scroll down and we can understand why this exists, a brief description, we have a source, we have dates of publication, we have all the metadata that we might need if we want to operationally use this data set or if we want to understand why it's here. But what's even more interesting is that we have the data quality specifications. We can read about the details of the data construction itself, and also if we were ever going to use the data, what would be our reliance in terms of interpretability of that data set. What's probably going to be the most useful to us right now is looking at the attribute information. So for each polygon, there are a series of attributes that are attached as a table to those polygons. And those attributes have somewhat cryptic, sometimes useful names, but they have to be relatively short to make sense. So we have things like base BBL and M-Pluto BBL and things that might not be really apparent in terms of what they mean to us when we first look at them, but we have a description that tells us something about what that attribute tells us about the polygon that we happen to be looking at. It also tells us whether it's a text or some sort of a numeric field and so on. If we scroll down here though, this is the one that I want to bring your attention to, height roof. And it tells you, I'm just going to read it to you from here, building height is calculated as the difference from the building elevation from the elevation point feature class and the elevation in the interpolated tin model. This is the height of the roof above the ground elevation, not the height above sea level. If this record is 0, that means that the information wasn't available. So in sort of technical jargon, what that's saying is it is not the height of the building above sea level, but it is the relative height of the building above the ground where it sits. This is the attribute that we're going to look at to extrude our buildings into three-dimensional objects so that we can place them on a map and take a look at what's going on. So it's possible to follow through the links to find where this data is actually stored. We can look at the New York City Open Data website, and they provide all of this information. Anybody can go and download it. You can use it. You can take a look at it. You can create maps. If you want to try this yourself, and I urge you to try it, it's really quite cool. Amaze your family and friends, you know, when we're allowed to actually see them again because of COVID. But regardless, it allows us to see all of the areas for which we have data. So for those of you that aren't familiar with where we are, we've got Toronto all the way over here, New York City down over here, we've got Long Island, and if we zoom in, each of these points represents the location of a single polygon or a building in New York City. So if we keep zooming in here, I mean, there are a lot of buildings and a lot of tall buildings in New York City and in Manhattan particularly. We can see that if we zoom in, we can see that there are polygons for individual buildings. The dot indicates that there's a record, and then all of those attributes are attached to that polygon. So I've gone and actually downloaded this data set, but I'm going to just zoom out a little bit so we can see what this place looks like. We can see that there are very few buildings in Central Park. There are a few. They're probably not very tall. If anybody's ever been to New York City and been to Central Park, you'll know that it's a relatively interesting place in the middle of a really big bustling city. A lot of really cool spots. But again, we've got data about all of the buildings. So what I want to do is bring this data set into QGIS. So I'm just going to move this out of the way for now. And I have the data set which I've downloaded and I have unzipped because it came in zipped format. And I'm going to grab that data set and I'm going to simply drag it into QGIS. Now, to make things move a little bit faster, what I've done previous to today's lab is that I took a subset of Lower Manhattan and I clipped that out and I got rid of all the rest of the buildings because to process that many records would simply take much too long for a meaningful demonstration and tutorial today. So I've added these in. They show up green, which is a color that you may or may not like. We could very easily make sure that this layer is selected by left-clicking on it and going up here to the styling panel and going in here and saying, you know what, I want to change what this color looks like. So let's choose something maybe here, maybe this blue. I mean, who knows? And we click apply. And we can close this window by clicking on the little X, and now all of the buildings are showing in blue. We can zoom in and we can see the individual outlines of the buildings. We can zoom out very clearly. We can see where the roads are and so on. We can right click on this layer and open up the attribute table. So now we have for each record, that is each polygon, we have one row of data. And we have all of those attributes for which we saw the metadata earlier. So with that being the case, we can look over to this column here, height roof, and we can see the height of the actual buildings. Now this is America. Remember, the heights are given to us in feet, not in meters. It'd be really, really tall buildings. But we have the heights of the individual buildings. We want to take that height value and extrude or make that polygon into a volume so that it represents the massing or the block structure of that building. I'm just going to close this for now. I'm going to show you how to do that in just a moment. But it's really hard to navigate all these buildings, particularly if you might not be familiar with New York City. What we might want to do is put a backdrop on here so that we have spatial context. If you've added those plugins which I mentioned earlier, you'll notice that there's a series of buttons that are added to your toolbar. Now they might be here, they might be over there. It depends on sort of where you have space and where the software adds things and what other plugins you may have already installed. But find these little globes, find the one with the little plus on it, click on there, and you can choose any background you want. I'm going to go to OSM, which is the OpenStreetMap, and I'm just going to add the standard OpenStreetMap base layer to my viewer. So here we go. There it is. And notice that we have it beneath the polygons because it is the backdrop and we want the polygons to draw on top of this map. If I were to change the order of these things, we wouldn't see the buildings because the map would be drawn on top of them and it would not be visible to us. So let's keep the OpenStreetMap below, and we have our buildings on top. We can uncheck the buildings. We can see that there's a lot of information there on this background map, but we now have the buildings on top. And we can sort of zoom out and see the detail. You can see where I cut the data set right there. We have a little bit going down here into Brooklyn and so on. Okay, so now that we've got this in pretty good shape, we can also right click on this layer here and go to Properties. And under this little wrench configuration page, we can go down and find the Query Builder button. And under Query Builder, we are going to choose roof height. And I'm going to say roof height greater than 100. What that says is all the shorter buildings I'm not going to worry about. I'm going to take only the ones that have a substantial height. And it also gets rid of the ones that were left blank or had 0, which are the buildings for which information doesn't exist. So we sort of clean out some of the stuff that's just going to sort of gum up the works. And that's a value that you can play with and see how that changes things. Okay, we hit OK, we hit Apply, and then OK. And now a lot of those buildings have disappeared from the map. They're still in the data set. It's just that they've been filtered out based on the query that I built. All right, now comes time for the fun stuff. And we're going to click on this QGIS 2.3.js toolbar button. It says that it's called the exporter. So we click on there and we end up with this preview pane panel that's going to allow us to build the three-dimensional elements and then sort of switch over into exporting it into something that's going to allow us to do something really quite fun. The first thing that we're going to do is we're going to put the background on as a flat plane. So this basically just says, here is my base elevation. And Manhattan's relatively flat, and we're just going to assume that it's flat for this demonstration purpose. It could be that we actually have a digital elevation layer that we add here, but for now, this is all that we're going to do. And then we're going to add the polygons from this geo export file. That's the actual building heights that we're dealing with. We're going to right click on there, select Properties. I'm just going to bring this down so it's a little bit more center. And in terms of object type, we're going to choose Extruded. That is, we're going to go from the polygon that's drawn on the ground and we're going to extrude it out of the ground surface. And we can choose that the height of that object is going to come from this field, which is height of the roof. So we're going to double click on there and remove that junk there. And we're going to hit OK. And I'm going to hit Apply. And what's happening here is that based on the scale, those buildings look tremendously tall. That's not going to be very useful. So what I can do is I can go back to this little equation editor here and say, well, we want the height of the roof, but I'm going to scale it down so that it makes a little bit more sense. And I'm going to try a value like this, hit OK, hit apply, still a little bit too big. I can go in here and shrink them down a little bit more. Even still, some of these buildings look a little bit too high. So let's put another 0 in there. Now we've got buildings that are much more in tune with the size that makes sense to us. We're going to click OK. And we can now, with our mouse, move this around and look at those buildings. It looks a little bit hazy and not so great, but just bear with me. It's going to get there. This is just the preview mode. When we seem like we're happy with the layout, we're going to export to web. And what we're going to do is we can leave index.html as the file name, but we're going to choose a location. Maybe I'm going to create a folder on my desktop, and it's going to be called NYC demo. And I'm going to hit enter. I'm going to select that folder. That's where it's going to write all of the output to. And then it's really important that we click enable the viewer to run locally. When we do that, we select this template, it's fine, and we hit export. We wait just a little bit. It's all done. We can then close this. And what's really cool is that I'm going to now open up that index.html file. So this is the one that we just created here. I'm going to double click on it. It's going to open up a web browser that looks like this. And that's pretty amazing. We have this 3D visualization of our buildings, but what's even more fun is that we can hold down our left mouse button and we can drag and rotate the view of New York City in any way that we want. We can use the scroll wheel on our mouse to zoom in and out. We can then tilt the buildings and get a sense of what downtown Manhattan looks like. We can hold down the control button, and as we drag with our left mouse button, we can move the scene left to right. We can use the Alt button to rotate the scene, and then of course just tilt it up and down and spin it around without holding down any keys whatsoever. So we get a really good idea. You can see the big gap that's right here. This is Broadway, that straight line that runs through New York City. That's a huge sight line, pretty neat. But we've done now is we've taken those regular polygons, we've extruded them to 3 dimensions, we've plopped them on a map, we've produced a viewer that we can now interact with. We could actually take these files and put them on a website if we wanted to create a really great visualization. Now the really cool thing is that there's a whole series of data sets that are provided by Microsoft that have building heights for sort of the entire world provided. I'm going to get you that information as well, and you can give that stuff a shot. I also have one more example. I'm going to run that in ArcGIS for you, but for that I'm going to sign off, switch over my software, and I'll be back. Okay, I have now switched over to ArcGIS, and I have my York University VPN running so that it authenticates very nicely and I don't have to deal with passwords all the time, and ensuring that I'm allowed to use the software. What I've done is I have launched an instance of ArcScene. And ArcScene is what used to be sort of the classic way to produce 3-dimensional content in ArcGIS. Now using ArcGIS Pro, there are many additional opportunities which are maybe a little bit better, but given that the learning curve for getting to up and running in Pro is substantially more, we're not going to jump into that in this introductory geomatics course. What I am going to do is I'm going to bring the same file that we were just looking at for Manhattan into ArcScene. I'm simply going to drag that over, and we see that it draws it here. Again, it draws it in green for some reason. Maybe we want to change the color of our buildings. We can do that. We can scroll in and out to look at what the building footprints look like. We can use the various tools up here, this one here for navigating. So we can use the mouse and hold the button down, and we can tilt the scene up and down. Notice that it's still flat. We don't have the three-dimensional aspects extruded here yet. We can use the fly button, so we can just click on a location and have this bird fly us around, and it's a little bit hard to figure out the navigation, but we'll leave that to you to play with. It's a little bit of a mess. I'm going to try to get back to our full extent by hitting this little globe here. And what I really want to do is build the extrusion. So we're going to right click on this level, go to properties, and we are going to make sure that we're on the extrusion tab. We're going to click on this checkbox that tells us that we want to extrude features on this layer. And then we're going to click this little calculator, which is going to allow us to enter the expression. Of course, we could enter the expression directly here, but we might not know exactly what the attributes were called, so it's always nicer to go back in here and select roof height. And if we click OK, it puts it in here. And if I click apply, we notice again that we have the problem where our building heights are much too big. So I'm going to simply multiply by some number to make them smaller. And that was a good guess. I've done this a few times. I think I have just memorized the number of zeros to put in. But again, we can see what downtown Manhattan or lower Manhattan looks like. And again, we can simply scroll in and pan around and look at what we've got. And it looks very much like what we had before. Unfortunately, putting the background in here is something that isn't really all that easy to do and is a little bit clunky, and it requires some workarounds. So I'm not going to do that here, but in ArcGIS Pro, that's something that is relatively straightforward and easy to do. So for this kind of thing, doing the work in QGIS might be actually a little bit simpler until we get to a certain level where if we're already working in ArcGIS, then to go to ArcGIS Pro and to do it there won't be as big of an issue. I have one more example that I'd like to show you, and I'm going to click on the new scene. We're going to simply make a blank scene. We're not going to save those. And I'm going to bring your attention to this website. Again, I'll give you the URL larger, but this is the United States of America population database in GIS form. And it's very easy to download. You can read about it on this page. I've already gone ahead and downloaded it, so I'm not going to do that right now. I'm simply going to navigate to where I have that file on my computer, and I am going to drag that layer into the viewer. Again, still in ArcScene. So we can see that we've got the mainland United States, we've got Hawaii out here, and we have Alaska. It doesn't look like we have Puerto Rico and so on here, but again, what we have are the states, and they've been colored based on population. And the coloring maybe not all that exciting, but what we want to do is extrude the boundaries of the states to correspond to the number of people that are living there. If we were to right click on here and look at the attribute table, we would see that there's a whole series of attributes available to us. And there's a whole series of them. We're just going to look at one of them today just to demonstrate how it works with simply a different data set, something that you can easily download and play with and produce maps on your own with. So we're going to again right click on the layer, head down to Properties, find the Extrusion tab, click on Extrude, go to the calculator, and we're going to choose population in the year 2010. And we're going to click OK. We're going to hit apply, and we have the same problem that the scaling, the vertical scale isn't really known. So what we need to do for visual purposes is to scale something down that's going to make it visible on the screen. So again, maybe we'll multiply it by something that's going to shrink them a little bit. Maybe that's not quite enough. Let's go a little bit more. Let's go a little bit more. And now, okay, we might be happy with that. We can see the states that have higher extrusions have higher populations. So nothing really here surprising and out of the realm of expectation. A lot of people in California, lots of people in Texas, and so on, and in New York State and so on, and Florida, we can very quickly produce maps that have a third dimensional element to them so that we can start to visualize more complex data. So when we think about visualization and extrusion, it really is about taking an attribute and drawing it so that it has height, whether it's building, population, maybe it's the level of a certain contaminant, maybe it is depth of snow, amount of precipitation, annual mean temperature. All of these things become easy to do when we think of the visualization in 3D. So until next time, have some fun with some 3D, and we'll talk to you next week.